Okay, good evening, good morning, good afternoon. Today's session, we are going to learn about the inverse of a matrix. So finding inverse of a matrix. Okay, how do you find the inverse of a matrix? Apply the Gauss-Jordan method. So before you find the inverse of a particular matrix, you have to apply the Gauss-Jordan method. That's the ERO, the arrow operation there, elementary rule operation. So you are saying we know that A multiplied by the inverse of A gives us what the identity matrix. Now, what do you mean by A and A inverse like this? So the A is the matrix given, and the A superscript negative one like this. It's what the inverse of this A. Now we are saying when you multiply a particular matrix by its inverse, you are getting what? You are going to get the identity matrix. So being a 2 by 2, you get the 2 by 2 identity matrix. If it is 3 by 3, you get what? The 3 by 3 identity matrix. So if you multiply a matrix by its inverse, you are going to get identity matrix. And as at now, I think you all know what identity matrix is. Type of matrix. All right, hold on from your camera.
Okay.
I'm back. So you all know what identity matrix is. So the identity matrix is made up of what? The elements are only ones and zeros, and the ones are in what? Diagonal. So ones are like this, and the rest are zeros. So we are, as I'm not going to worry myself to teach the identity matrix again because I taught that in our previous video. Now, okay. So suppose B is any matrix that satisfies A, B is equal to I. If you multiply the left side of both sides by what? AI, A inverse, we get this. So the final answer would be what? Identity matrix multiplying matrix B should give us what? The inverse. Now, why are you saying that the identity matrix? So here, this means B must be the inverse of A. We are getting IB. I stands for identity matrix in this scenario is equal to what? A inverse. Now we are getting this, but why are they saying that B must be the inverse of A? So they are saying the final answer should be the B must be what? The inverse of what? Is the minus one. Okay, so the B here will be what? The inverse of A. Why are they saying that? Well, they are having I here. They are saying that because this I here is an identity matrix, and when you multiply it by B, the special property of identity matrix is that any matrix multiplying the identity matrix, we get that the answer as what? The matrix multiplying identity matrix. So here B is the matrix multiplying identity matrix. So when you multiply B by I, your final answer will be the B itself. So therefore, the B represents what? The inverse of what? A. Because of this, we can apply the Gauss-Jordan method to find the inverse of what? A matrix. Okay, so let's move on. You understand that in what the workings I'll be doing. So we are saying the inverse of A. Let A be an invertible matrix. Let A be an invertible matrix. The inverse of A can be obtained through the Gauss-Jordan method by applying the following. Now, first of all, if I may ask, what is meant by inventable matrix? This one, inventable. There's any idea? Who can tell me the meaning of inventable matrix? Have any idea? Hello, any idea? Okay, so we are saying the inventable matrix is what? The n by n matrix. N by n matrix. And when we say n by n, it means a square matrix. So square matrix, we have 2 by 2, we have 3 by 3, we have 4 by 4, 5 by 5, and the rest. But I think for the purpose of this course, we are using this, I think this, but mostly it's 2 by 2 and 3 by 3. So when you hear the word inventable, or when you see inventable matrix, it simply means square matrix. Just take it that way. It simply means square matrix. Now we are saying let A be what? Let A be inventable matrix. The inverse of A can be obtained through the Gauss-Jordan method by applying the following. Now you are saying that step 1, form the augmented matrix. That's the AI. Step 2, transform the augmented matrix here, AI here, into the form IB. The resulting one will be, hold on for me, see, I'm coming. Okay, let's continue. So transform AI into the form IB. The resulting matrix B is the inverse of what matrix A. Now we are going to learn these steps in the on the whiteboard. Okay, so they are saying first of all, when you have A to be inventable, now before you find the inverse of a matrix, you have to make sure that that matrix given is what? An inventable matrix. It's a square matrix. Before you find the inverse of that matrix, the matrix given must be what? A square matrix. So the inverse of A can be obtained too. So the square matrix, let's say they give us what? 3 by 3. So let's say they give us the 3 by 3. They give us 3, 1, 4, 6, 0, 5, 8, 4 again, then right 7. Okay, so this is a 3 by 3 matrix. Now we are saying if you are getting this as your matrix given and you are asked to find the inverse of it, the first step is what? Form the augmented matrix. Form the augmented matrix. Now, how do you form the augmented matrix? You just augment with the what? The identity matrix of the what? Matrix given. So the identity matrix of this one will be a 3 by 3 identity matrix, and you will have 1, 0, 0, 0, 1, 0, 0, 0, 1. So we are getting this. So we are saying from the augmented matrix AI, that's what we have done. We are saying transform AI. You should transform this into what? IB. Now we are saying after getting this, the A here must change what? I. That it must change what? You must transform it from A to what? Identity matrix. So we must transform the 3 here must change to 1. The 1 here must change to 0. The 4 here must change to 0. The 6 must change to 0. The 0 here must change to 1. The 5 must change to 0. The 8 must transform to 0. The 4 must transform to 0. The 7 here must transform to 1. And by performing that because you augmented the identity matrix of the A, because you augmented with you form the augmented matrix I. By doing so, every operation you perform here will extend to affect this row too. By doing so, your final answer will not change to I. It will change to a particular number that we don't know. You get it? So yeah, let me represent the unknown answers with x, 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 x. So this one, let's say matrix X. So you see that this was initially matrix A. And we are saying the rule is saying that we should transform it to matrix what? I. We've transformed that into matrix I. Now by transforming, because you've augmented the matrix with the identity matrix here, everything you perform here, you perform on this row will extend to affect the I here too. So by doing so, your final answer will not remain the same. The I will not remain the same. The I will also change. And that change, or the newly matrix, that is X, becomes our inverse of what? The A here, because we are saying we are getting what? I and X now. This matrix here is multiplying the X matrix here. And we are saying when, so I multiplying what? X. And we are saying with the special properties of what? Identity matrix. When you multiply a matrix by a normal matrix, the answer should give us what? The ordinary matrix. So therefore, our answer becomes this one. And that X becomes our inverse of matrix A, which was initially given here. All right, so any questions so far? Before we pick a question, then you solve for it. Any questions so far?
No question.
All right. So we are giving a particular matrix. Find the inverse of the find the inverse of the given matrix. I think that there was a typo. So we are saying the inverse given must be at an inventable matrix. Before you find the inverse of a matrix, that matrix given must be what? A square matrix or inventable matrix. Why? Because you augment with the what? Identity matrix before you start to work. And all identity matrices are square matrices. All identity matrices are what? Inventable matrices. Hold on for me. Okay, thank you. So, because you augment with what? An identity matrix, that's why we are saying that the given matrix must be what? An inventable or square matrix. Because you augment it, and by augmenting it, you have to augment with what? An identity matrix. And all identity matrices are inventable matrices. All identity matrices, yes, are inventable matrices. Or how do I say the plural of matrix? I've forgotten. Okay, so every square matrix, like before you find the identity matrix, you have to get it as what? A square matrix. That's why we have the 2 by 2, 3 by 3, 4 by 4. You don't have 3 by 2 identity matrix. No. You don't have 4 by 3 identity matrix. It is 2 by 2 identity matrix, 3 by 3. Their dimensions, they are square. Like the number of rows are equal to what? The number of columns. Okay, so let's move on to solve the example here. Let's move on to solve the example here. Okay, so the first step was saying that you should form the augment matrix. I'm coming. Okay. So the resulting, so we have to form the augmented matrix. So we are going to form the augmented matrix. We are going to augment with the identity matrix. And so, which dimension are we going to use here? Is it 2 by 2, 3 by 3, or 4 by 3, 4 by 4?
2 by 2.
2 by 2, good, because the matrix here is 2 by 2 matrix. Then after that, we are going to transform the AI to what? IB. Okay, so let's start. So let me switch the whiteboard. And I didn't even. Okay, so it was matrix A. Was 2, 4, 1, 0. So the first step is saying this is a given matrix and it's an inventable n by n or square matrix. So the first step is saying that we have to form the augmented matrix. And by forming the augmented matrix, we have 2, 1, 4, 0. Then we augment with the identity matrix of what? The dimension given. So it is 2 by 2. So the 2 by 2 dimension will be written as 1 0 0 1. All right. Okay. Okay, let's try again. All right. So 2410, you augment it with what? The identity matrix of the matrix given. So this was 2 by 2. So you form the what? 2 by 2 identity matrix. You augment with the matrix given. So this one becomes A. This one becomes what? I. So first of all, we've formed the augmented matrix. That's the first step we are done. So let's move on to the second step. The second step is saying we must transform AI into IB. How do we transform that? The A here must tend to the I, and the I must tend to something different. We can only do that by using what? The Gauss-Jordan method, that the ERO, elementary row operations. That's what we did in our last session or in our last meeting. Yes. So we move on to transform the matrix here to what? We transform the matrix here. So we form the AI. So we are going to transform it to what? IB. How do we start that? And we are saying we are going to use the Gauss-Jordan method. So step one, I would say that. So we must change the row here, like the element here, to be what? Identity matrix. So this one should tend to what? 1. The 4 must tend to 0. 1 must tend to what? 0. 0 must tend to what? 1. Okay, let's start. So with the operations, I'll start with the first one. Let's divide row 1 by 2. Row 1 divided by 2. Note, you cannot divide a row by another row. You cannot multiply a row by another row. You can only add a row to another row, subtract a row from another row. You cannot multiply 2 rows, you cannot divide 2 rows, but you can add 2 rows, you can subtract a row from another. You can only multiply 1 row with what? A non-zero scalar. You can only divide 1 row with what? Non-zero scalar. What do you mean by non-zero scalar? Non-zero scalar means any number that's not what? 0. It can be negative or positive. Okay, so my first operation is let's divide row 1 by 2. So which is this one is 1. So 2 divided by 2, we are getting 1. 4 divided by 2, we are getting what? 2. So we are performing it on the row 1. So nothing will affect row 2. So 1 0. Because we've augmented it, everything we perform on this row will extend to affect the elements here on the first row in matrix I. So the operations will extend to this part. So it will affect the second row, so 0 1 will remain. Now, 1 divided by 2, you are going to get half. 0 divided by 2, you are getting 0. So every operation we perform here, because of the augmentation, we must extend to affect this one too. You get it. Okay. So every operation you perform here must extend to affect this one too. That's why we extended it. We learned that in our previous video. Okay, now what is the next step? Because we are transforming the matrix A here into an identity matrix. So we are going to make A look like what? The matrix I here. So we've gotten this. How do you think the next one will be? For me, I would say that let's subtract row 1 from row 2. So row 2 minus row 1, you get it. So what will be the effect or the outcome? So we subtract, and we are doing this on what? Row 2. We are performing this operation on row 2. The first one was performed on row 1. It's clear here. Okay. So row 1, nothing will affect it because we are performing it on row 2. Half 0. Then now we are seeing 1 minus 1 will give us what? 0. 0 minus 2 here will give us what? Minus 2. 0 minus half will give us what? Minus half. 1 minus 0 will give us what? 1. Now we've gotten the 1, we've gotten the 0. So we need these two to change what? 0. This negative 2 to change to what? 1. Okay. So let's move on. So the next operation, I would say let's multiply root 2 by negative half. Let's multiply root 2 by negative what? Half. So what will be the answer? So the answer will be minus 1 over 2 times root 2. We are doing that on root 2, so root 1, nothing will change. So 1, 2, half 0. Okay. So here, negative half times root 2. The root 2 first element is 0, so we are going to get everything at 0. Negative 2. So negative 1 over 2 times root 2. The E here is what? Negative 2. We are going to get positive 1 here. So negative half times negative half. We are going to get positive 1 over 4. Is that?
Yeah. I
Okay.
said yeah.
Okay. So the next step is what? Negative 1 over 2 times root 2. The root 2, what is the positive 1? So we are getting negative 1 over 2 here. Okay. So we are gradually changing it. We are gradually changing it. In our identity element, identity matrix, we've gotten the 1, we've gotten the 0 here, we've gotten the 1 here. So it left but the 2 here, changing, transforming to at 0. So the fourth operation, I'll go for row 1 minus row 2. Row 1 minus row 2. Let me clean this. So operation 4. What? Row 1 minus what? Row 2. Okay, so we are performing this on what? Row 1. Performing this on row 1. So
Can I question?
Okay, ask.
Distributions, right?
Is it?
Can I say the fourth step? With the fourth steps, can I say 2 multiplying row 2 minus row 1?
2 multiplying 2 multiplying
row 2 minus 1.
2 multiplying
Row
root
2.
2 minus what? Row 1. Okay, so let's try that one and see. So which row are you going to perform this operation on? The row 2, right? Row 1.
Right, row 1.
Yes, because
No, we
here,
have operation on row 1.
yeah, because here we don't need to change anything. Because it's 0 here, 1 here, so we don't need to change anything. Okay, so let's check yours. So 2 root 2. Root 2, what is the 0?
Yeah.
Minus row 1. Row 1, what is the 1? So here will be 0 by 1 to give us negative 1. Which will change the 1 here to give like a negative number, and it will release us what? Another work. Because we only need this 2 to change, because identity matrix, the ones are in what? Diagonal. Yeah, in what? Diagonal. So you've gotten the 1, you've gotten the 0, you've gotten the 1. So the 1 are in diagonal. But these 2 must change what? 0, because you are saying identity matrix. It is made up of 1s and 0s, and the 1s are in diagonal. So with your answer, even if it will work, it will take you a long process. And when you are doing it, you have to be like smart or sharp with it, because you can even use 6 steps or 5 steps to finish everything. But you don't look sharp or something like that, you are going to spend the time on it. Like you're going to go through like 15 steps or something. But you see, this positive 1 has changed to what? Negative 1, and it will lead us to what? Plenty of workings. So I was saying, let's go for 1 minus what? Row 2. And it is going to be done on the row 1. So 1 here minus 0, we are getting 1. 2 minus 1, we are getting what? 1. Now, half minus 1 over 4, we are getting 1 over 4. 0 minus 0. So it will be 0 minus 1 over 2. So the minus are 2, so we are going to get plus. Let me confirm this one. You have confirmed that one for me.
0 minus minus.
Yes.
Positive half. It's positive half.
Yes, because we are saying row 1. So the row 1 was 0. So the row 1 was 0 minus row 2. The row 2 is already minus, so it will be another minus. Okay, so we are getting positive half, right?
Yeah.
So 1 over 2. Oh, sorry. We are performing that on row 1. Huh. We are performing that on row 1.
Okay. So we are not.
So we are going to have the positive 1 over 2 on top. Okay, so gradually. So it's left with the last step. We want the 1 here to change to 0. So this one, I think, is simple. We perform the same operation again. Row 1 minus row 2. And we perform it on what? Row 1. So the answer will be 1 minus 0, 0. So nothing will change here. Nothing will change here. It's only row 1. So the row 2, everything will remain intact, remain safe. So 1 over 4, negative 1 over 2. So 1 minus 0, minus 1, we are getting 0 here. 1 over 4 minus 1 over 4, we are getting 0. Half minus half minus 1. It's become plus. So here we can again get 4. Here we can plus. All right. So here we become 1. All right. So you see that we've gotten what? The identity matrix. Because the identity matrix of 2 by 2, it is 1, 0, 0, 1. We've gotten that. Now, the step was saying that we must what? Form the augmented matrix, and that's what we did here. The matrix was this. We formed the augmented matrix AI. The step 2 is saying that transform AI into form IB. Transform the form AI into IB. Now you see the identity matrix, it was at the right side, right? But here it can be found at the left side. So then this one, instead of the AI, it has changed to another matrix. Let's name as this one as B. So the step was saying that transform the form AI into the form IB. The resulting matrix B is the inverse of A. So the resulting matrix B here is the inverse of A, which is the matrix given here. Why are they saying we are having two matrices? Why are they saying that the inverse is not matrix I, but it's matrix B? Who can explain this one for me?
Come on.
The slide was saying that after your answer, after you've transformed AI into IB, the resulting matrix B is the inverse of A. Now with our work here, the resulting matrix B is this one. And they are saying that B is the answer or is serving as inverse of A. Why are we saying that the inverse is not I, but it is B? Because it is two matrices here. Why are we choosing only one as our answer? Who can explain this one for me? Can you explain it for me?
Okay. We are choosing B as an answer because when you multiply the identity matrix by the normal matrix, it will give you the same answer for what the normal matrix.
Good.
That's
so
why we are choosing the B.
Good, perfect answer. So you multiply I by B. Your final answer will be what? B. We are seeing the B here will serve as what? The inverse of the A, which was given in the question. So we are getting 0, 1, negative 1/2, then positive 1 here. So this becomes our final answer, or the inverse of what matrix A here. Now we can use determinant method, Cramer method, or something like that. So we can use it by because of uniformity, or for the sake of quantity or something like that. We are using what? The Gauss-Jordan method. And the Gauss-Jordan method is how it is performed. And I think this one should be simple for us. The operations, step 1, step 2, step 3, step 4, then those tasks will be the difficult aspect. But with the answer, I don't think it will be difficult for you. So with the operations, you have to be smart, you have to be sharp, you have to be thinking that how am I going to get transform the number here to 1? How am I going to transform a certain number to 0? Then you perform your functions or your formulas on it. Perform it on it. And then you do your subtraction, multiplication, division, addition, and so on. All right. So any question before I move on? So this one, they give us only one matrix. They give us only one matrix, and they asked us to what? Find the inverse of that matrix. But you can get a question whereby you will get what? This one matrix, you will get unknown variables. Then you will get resources. So it's like the one we did the other time. You are going to get a matrix giving unknown variables, then resources. So that one too, we can use this same inverse of a matrix to find unknown variables of what? A given expression. So as we did at that time, we use the identity matrix to solve for AX1, S2, S3. We can use the inverse matrix to solve for what? AX1, S2, S3. So any question before we move on? Any question? No question. So I guess you said
final answer.
Okay, it was
The final answer.
0, 1.
1 out of 4.
Okay.
0.
Thank you. It's
Minus
0, 1 over 4. Then minus 1
minus
2. Okay, thank you. Okay, so let's move on. So this is how they started it. They divided row 1 by 2, so started this, divided row 2 by -2. Row 1 minus row 2 times row 2. You see, we all got the same answer, but we used different formats. He used 1, 2, 3, 4. He went through what? 4 steps. But with mine, I went through at 3 steps. Did you see? Can you see that one? Do you understand? Like, so your smartness determine how long you are going to spend on the question. But I think here the lecture was very smart to use just only 4 steps to arrive at their answer. But for me, I went through 6 steps. But we all arrived at the same answer, 0, 1, 1 over 4, minus 1 over 2. So your smartness determines the time you spend on the question. For this type of this one, you have to think. You have to think deep to know the formulas or the functions to use, so as to shorten your time on the question. All right. So this is what I was saying. So solving systems of linear equation with matrix inverse. We are having what? 2 or more linear equations. We are having 2 or more linear equations. So linear equations. And we are asked to find the unknown variables with what? Matrix. How do you do that? We are going to learn that today. Okay. So we are saying, read this one.
Find the variables P1, P2, and P3 in the system of linear equations below. 2P1 plus 4P2 plus 8P3 equals 26. 5P1 plus 7P2 equals 38. 8P1 plus 12P2 plus 3P3 equals 66.
Okay, so this one is what? Linear equations. So they've given us 1, 2, 3 equations. And we are asked to rewrite it in the matrix form. And I think we know how to do that. I'm not going to worry myself here. So find the variables P1, P2, and P3 in the systems of linear equations below. So this one, the coefficient 2, 4, 8. Come down. So you can write. So this one stands for the P1s. This one stands for the P2s. Then this one stands for the third column stands for the P3s. Now let me teach you this one. So 2, 5, 8, 7, 4, 7, 12. That's what they've done here. 8. You see that we don't have any P3 in what equation? Linear equation 2. We don't have any P3. It's only P2 and P1. And because you created a third column for P3, when you reach equation 2, you cannot like put dash or something like that in that matrix. So there's no P3. Don't write dash. Just represent that one with 0. Then when we come to equation 3, the P3 is 2. Then you write it 2 there. They do the rest. So the equation first matrix contains what the coefficients of the equations. The second one, which is the x here, contains what the decision variables or in other words, the unknown variables that are yet to be calculated for, then equals your resources. So 26, 38, 66. That's what they've done. Now, before you solve for this, first of all, you must find the inverse of the given matrix, the matrix of the matrix of what? The coefficient. You have to find the inverse of it. After finding the inverse, you multiply it with the resources, you get your known values for this. Okay, so let me teach you this one. Please just record this one for me. So the matrix was 2, 4, 8, 4, 7, 12, 2, 0, 8. So first of all, you have to find the inverse of it. This one is very long, so I'm going to just teach you, like, then we just move on. So you augment, you form the augmented matrix. So this one, it is which type of identity matrix are you going to have? I mean the dimension. That is the dimension for it. 3 by 3. So the identity matrix must be 3 by 3. So 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay, so the ones are in diagonal. After getting this, you go through the arrow or the Gauss-Jordan method to transform the what? A here. So this is A. So you have to transform A here into I. So your final answer, you must get this. So you must get 1, 0, 0. So note, your final answer, the identity element will change its position to the first matrix. So you get like this 0, 0, 1. Then by doing so, by transforming 2 to 1, 4 to 0, 8 to 0, 4 to 0, 7 to 1 here, 0 here to 0, 8 or 0, so it will change. 8 to 0, 12 to 0, 2 to 1. By doing so, every operation you perform here, so if you divide a row by a non-zero scalar, you must perform the same operation for this one too. And by doing so, your answers here will change. So your final answer, before you get this one will also be like this: 0.7, 4.44, negative 2.8. It's very long. It will be long. That's why I'm taking the short course. I've done a first example with you, so you have to use that one to solve for this too. Because I'm only writing the final answer. Negative 3, 2 here, 0.2, 0.4, and 0.3. So this is your answer. So now the A here has changed to has transformed to I. Then the I here has transformed to different matrix called what? B. So now we are saying after forming the AI, you transform AI into IB. You've done that. Your final answer, you are saying B is the matrix. So your inverse of A now becomes what? The matrix. So inverse of A. So this was matrix A. So the inverse is 0.7, 4.4 minus 2.8, 2, -3 minus -0.5, then 0.2, 0.4, and what? 0.3. So this becomes your inverse. Now you are not done. If it was the matrix alone, you were finding the inverse for that matrix alone, this would have been your final answer. But in this case, they are asking us to use the inverse of that matrix to solve for the unknown variables P1, P2, and P3. Now with the first one, you see that the first one we did in the previous video, it is somehow different like this, but it's very, very similar. So take note of that. Because that one, with the first one, finding the identity, using the identity matrix to solve for P1, P2, P3. That one, we just what? Augment the resources, the B here, matrix B here, with what? Augment it with what? Matrix A here. So should we augment this with what? Resources. Then we work for it. So what? We change the A, or we transform the A to identity matrix. Then by changing it, this B2 will also change, and that one will become our answer. But with this one, we are going to use only the A here. Then you augment it with what? Identity matrix. You are not going to augment with what? The resources. You are going to augment with the identity matrix. And by augmenting with the identity matrix, you change the A to I, and that identity matrix to a different matrix, giving us matrix B. So you see that they've done everything here. They first of all worked for the inverse. By working for the inverse, you then multiply the inverse with the resources here. You multiply it with the resources, and your final answer will give you the P1, P2, P3. But with the previous one, you would have augmented the resources with the matrix here, the A here, and we work to change the A into I. Then by changing A into I, the B here will also change to, the resources here will also change to different figures. And that different, or the new figures we get, will be the value of the unknown variables. But this one is quite different. You just pick the A only, you don't augment with the resources, but you augment with an identity matrix. This is 3x3 identity matrix. Then you find the inverse. By finding the inverse, that you multiply the inverse with the resources, the answer you get will be what? Your values for X1, P1, P2, P3. So in this case, P1 is 0.6, P2 is 5, P3 is what? 0.6. Okay, so do you have any question here?
No, sir.
Do you have any question?
No question.
Okay, thank you. So by performing all of these, what we have done so far today, we can use Microsoft Excel to perform all the operations. You can use the, I've taught you how to multiply, add, divide, subtract, those that name a matrix and those tasks. But with this one, and I've taught you, okay, I think I didn't teach you the inverse. We are going to use Microsoft Office to work for the inverse of a matrix. I'm going to use MS Excel to find unknown variables or decision variables. Right, so let me open my Microsoft Excel here. Okay, so the okay, so let's enter our destiny, our matrix, the one we just solved. The one we just solved. Or let me use this one. let me use this and solve the inverse of it. The first one we did the 2 by 2. This one, the matrix 2 by 2, the inventable matrix here. Let me use 2, 4, 1, 0. Let me find the inverse of it. And let me see if I can get 0, 1, 1 over 4, negative 1 over 2. Okay, so share this one first. Okay, so can you see the Excel?
Yeah.
So it was matrix A equals, so it was 2, 4,
1, 0.
1, 0, 8, so 0. Okay, so I've taught you how to name particular matrix. So you just click on the first cell, you highlight true. Then you go to, whilst you've selected your what cells to be named, you go to the name box here, you click on it. Let's name it as what cell matrix A. Press enter. So you've named that matrix as what. You can also give borderlines to it. Okay, so you've done everything. Now let's move on to find the inverse. So you type A inverse minus 1. So the minus 1, make it superscript. Superscript. Okay. Superscript. So it's equal to, you see that this one is 2 by 2. So we're having 1, 2, 3, 4, 4 cells. So we just highlight 4 cells. Highlight 4 cells like this. Then once you've highlighted it, don't press anything, just press equal to, press equal sign. You type in the function, the built-in function in Excel. Mean first. That's it. And you click on it. Then you just type in the name of the matrix you want to find the inverse. In this case, the name was what? We named this one as A. So you just type in A. Don't press on enter, press shift, control, and enter. Shift, control, and enter. And have you seen we've gotten the answers we got? Because we got in the question we got, see 0, 1, 0.5 here. The 0.25 here is the same as 1 over 4. Minus 0.5 is the same as the negative half. Let's see. We got what? 0 here is 0 to 1 here was 1. 0.25 is the same as 1 over 4. Minus 0.5 is the same as what? Minus 1 over 2. So this is how you find, basically, this is how you find the inverse of a particular matrix. This is how you find the inverse of a particular matrix. Now we are going to use, we are going to find the inverse of a particular matrix and find the unknown variables. You get it? And find the unknown variables. Okay, so let's clear everything here and just enter our new one. I mean this 2, 4, 8, 1. So let's enter it. It was 2, 2, 5, 8, 12, 2, 0, 7, 4, 8. Then we know how to, you just select it, you click on the name box, you type A. You give an outline, you type A here, you press enter. You are good to go. Then you write A inverse, A minus 1. The minus 1, you make it superscript. Highlight the minus 1. You click here, superscript. Okay. equal to 3. Okay. So this one is the 3 by 3 matrix. So we just highlight the 3 by 3 matrix. Pass highlighted, don't press on anything, just enter or press on equals on your keyboard. Type the function inverse. You click on it. You type in the alphabet which you use to name your what matrix that you are about to find the inverse. You type A. See that the moment you type A, it is highlighted with what? Blue borders. It was black, but the moment you type A, it has not highlighted. Then you press on Shift Control Enter. See that we've gotten the answer on Google Chrome. So let's cross check. So you got it to 0.7 minus 0.5, 0.2, 0.4 minus 3, 4.4 minus 2.8, 2, negative 0.3. So with Excel, if you know it, it's very, very simple. Easy. Within 5 seconds or something, I've done it. But for the sake of example purpose, they are saying you should learn Gauss Jordan, that long story. You have to divide this rule by a number, subtract a rule from another rule, add 2 rules, and interchange before you get the inverse. But with Excel, you can do it simple. So they are saying now that we've gotten what? We've gotten the identity, we have gotten the inverse here. Now that we've gotten the inverse, we should multiply the inverse with the resources. So the resources was 26, 38, and 66. So you multiply it with it. So the resources 26, 38, and what? 66. So you just give it a border. Then we come down like this. Now we are going to find the unknown variables for P1, P2, P2, and P3. Okay. So just highlight it like this. Okay, we didn't name this one too. So let me name this one to be, let's say, B percenter. Let's name this one to be what? C percenter. So after doing it, okay. So let me name it D. Okay. See that when you highlight it is D. When you highlight it should be B. All right. So you are going to find values for P1, P2, P3. We are saying we multiply the inverse by what? The resources. So let's multiply. Now in Excel, when you are multiplying, you don't use asterisk. When you are multiplying a matrix, when you are multiplying normal figure is that the 2 figures involved, then you add asterisk, division, slash, then multiplication, division, you use the plus and minus. The division, you use slash. Multiplication, you use asterisk. But with matrix, when we are multiplying, we have a built-in function. So the built-in function is M. You first of all press equal to before you type the function. M mod. You get it. So M, then MMULT. You click on that function. Then you select your first matrix to be what? Multiplied. So the first matrix was B, the inverse here. You see that the moment I press on B, it has been highlighted, comma, you bring comma. You type your next resource matrix. That the resource is here. That's the matrix D. You see that one too. So we are having what? Blue here, red here. Then, as I said, you press Shift, Control, Enter to give you answer. So P1 is 0.6, P2 is 5, P3 is 0.6. So let's check. See, yeah, the same. Nothing changes. You see. So P1 is 0.6 is here, P2 is 5, P3 is 0.6. Simple as that. So any question Any question? Any question?
Okay, so with the linear equation, we use only inverse matrix to solve for the linear equation.
Mm. Come again. I didn't get your question.
I said with the linear equation, is it only the inverse matrix that we use to solve for the linear equation?
The linear equation, is it only the inverse we use to solve the linear equation? I don't get it. Yeah, come again.
Yeah, the inverse. Like,
are you talking about the unknown variables? Come again. I want to get your question.
With variables, not unknown variables, with variables, like linear equations with variables.
A linear equation, definitely it will have unknown variable.
I don't even know how to put that. Okay, so with the unknown variables, okay, let me say 3x1 plus x2 plus x3 equals 40. With those type of questions, so are we going to use only the inverse matrix? We use the inverse matrix to solve for that type of equation.
No, you can use the identity matrix too. The identity matrix. You can use the identity matrix. That's what we learned the other time. So I even mentioned that before I started this work. I said with identity matrix and inverse, using it to find unknown variables, they are quite similar, but they are different. Because this one got something here. Got this. This one we use identity matrix. Just what identity matrix to solve for the linear equation here. We didn't use inverse. So with the identity matrix, you first of all change the normal matrix here. You augment, you do your operations, you get your final answer. You get it. You get it here. So 1 0. This.
Are you trying to say that it depends on the question?
You said.
Are you trying to say that it depends on the question?
Yeah, the question will tell you use the inverse of a matrix to solve for the known variables. Use the identity. I don't know how they said their question, but I think the question will pinpoint that.
Okay.
That use the inverse or use the identity matrix method. They are quite similar. So the meeting will be ending soon. Let's rejoin it soon. All right. Thank you. Okay, so with the identity matrix method, you are going to first of all augment with the resources. So we augment with the resources. That's what they've done here. But the inverse, you are not going to augment with the resources, but you are going to rather augment with the identity matrix of that matrix given. Then you wait till the matrix given changes to identity matrix. By doing so, that identity matrix which you augmented will change to that something else. So the something else it changed to will then becomes your inverse of that matrix. Then use the matrix to multiply the resources before you get your unknown variables. But with the identity, straight away you augment with the resources. Then you wait till you get your what matrix changes or transformed to what identity matrix. And by the time it changes to identity matrix, the resources you augmented to will change. The 40-30 system, it is no more 40-30 system, it is 5-25, 70.5. 5, 7.5, 17.5. So the 5, 7.5, 17.5 will then be your answer for X1, S2, S3. But with the inverse, you are going to augment with the identity matrix. You wait till you get your identity matrix here. Then your matrix you augmented with the identity matrix will change to particular numbers. So it changes to 0, 1, 1, 4, minus 1 over 2. That matrix will be then becomes your answer, or it becomes your inverse of the matrix you were given the question. So if you want to find unknown variable, You find the inverse of the matrix given first. This case 258, 4712, 802. Then you use that to multiply after finding the inverse. So this is the inverse. Then you multiply with the resources. But with the identity, you don't multiply with the resources, you augment with the resources. So it's somewhat the opposite of the other. You get it? The inverse is the opposite of the identity matrix. So you use the inverse here to multiply the resources, 26, 66. That's what they've done. Then you multiply it. When you multiply it, your final answer then becomes your final answer for P1, P2, P3. Do you get it now?
Yeah.
Okay. So let's use the Excel method to solve for the values of this S1, S2, and see whether you are going to get the 5, 7.5, 17.5. Okay, so the matrix was this. This one, they use the identity matrix, but with the one I'm going to solve in this, I'm going to use the inverse with the same matrix here. So that's what I've done here. That's what I've done here. So let me name this one to kill. Okay, so then the resources to, let me name that one to K.
I can't see.
Okay, I'm coming. Okay, so I just named, can you see it now?
Yeah.
I just named the matrix here to kill, the matrix here to what? K. So let me change the name here. K. Then matrix what? Kill. So first of all, you have to find the inverse of matrix kill. You have to find the inverse of matrix kill. So kill negative 1 superscript. Okay, so that one, then it is 3 by 3. I'm going to find inverse 3 by 3. So it is what? Invertible matrix, n by n, square matrix. So you select your square matrix, that's 3 by 3. Far selected or highlighted, the cells been highlighted, just press on equal sign. You are going to find inverse. You type in the built-in function in Excel, mean verse. You click on it. Then you key in the alphabet or the alphabet you use to represent the matrix. So the matrix we want to find the inverse is what? K. Just type in K.
Yeah.
You see that the moment you type K, it has been highlighted to blue. See, it was black. The moment you type K, look at the borders. I'm pressing K to change to blue. See, it has changed. Then you press what? Shift, Control, Enter. You see, you've gotten the inverse. Now we are saying to get the value of x1, x1, x2, and x3, we are to multiply the inverse of the matrix we solved for by the resources. That is the inverse method. So as highlighted, it is the P1, P2, P3, it is what? 3 by 1. So highlight the 3 cells, equal sign. We are not going to multiply the Q here by the K. We are going to multiply the Q inverse by the K. Look at the difference. The Q is the normal matrix, but we find the inverse. So we multiply the inverse by K. So inverse, so we type in inverse. Then you select this matrix. Okay, you can select it like this. Click on it, drag it across, comma. then you type in K. Then shift Control Enter. Okay. I have to name this one. Come on.
We are multiplying the two. So why didn't you
That
do
was my mistake. That was my mistake. Thank you. So you see that this one has been selected, this one has been selected. So shift Control Enter. Hope we can hear you.
Yeah.
Okay. So 17.5, 7.5, 17.5. Isn't it the same as the one here?
Yeah. That is
7.5, 17.5. So with Excel, if you know how to use it, simple, you are done. I'm not going to go through all these steps. So do you have any question now? Do you have any question?
No question.
No
question. Everything is fine.
Okay, so let's move on to inequalities. All what we've done is equality. Now we are moving into inequality. Now inequalities means the negative sign of equal to is not equal. In inequality, it's not equal. So a linear inequality is of the form this. We know all of this. So let me give you the keywords. In business modeling, when we hear this phrase, at most means greater than, at most means what? Less than or equal to. At least means greater than or equal to. Has available to spend. So has available to spend. If you have something available to spend, you shouldn't spend more than that. So that one too means less than or equal to. So these are the keywords. If we are reading a word problem in inequalities modeling, and we hear at most, like, oh, you shouldn't spend at most. You should spend at most 50 Ghana cedis. You should spend at most 100. Means what you spend must not exceed 100 cedis. So it's either 100 cedis or 99 coming downwards to 1 cedi, 50 pesos and so on. So what you spend should not be what? Greater than 100 cedis. Either it's equal to 100 cedis or it's lesser to 100 cedis. So it's greater than or equal to less than. This one is greater than at least. Oh, this match we should score at least 2 goals. Meaning the 2 goals should be the least. It must be 2 or more. Then the has available to spend is less than or equal to. So less than or equal to, less than or equal to, greater than or equal to, less than or equal to. So these are the keywords I will give it to you. So let's move back to the screen. So here, they are saying a household has 300 cedis to spend on rice and soda drinks. A bag of rice costs 20 cedis and a pack of soda drink costs 15. Write a relation detailing how the available 300 Ghana cedis is spent. Mind you, this is inequalities. If it were to be equalities, we would have what? Equate like created a listing depth of expression and move on. But this one is inequality. So inequality, you just use greater than or what, less than, greater than or equal to or less than or equal to. You get it. So first of all, so now how many decision variables are we having here? This one we've done it. So how many decision variables are we having here? And
2. That is the number of
X1 represents what?
quantity of rice and the quantity of soda.
So what is the price of soda what or something? So 20 X1, right? Do you get that one? You said the X1,
Yeah,
let's
20
represent X1 with the number of bags of rice and S2 represent number of what? Pack of soda drinks. Now we take S1, this one number of quantity of bag of rice. The unit or the price of bag of rice is 20 cedis, so 20 by the unknown quantity plus 15 X2. You've already done this, so I'm not going to worry myself or stress myself. Now, looking at the statement, what will be what will be the sign to use? This is greater than or equal to, less than or equal to, or equal to, because we are dealing with inequality and we are saying the household has 300 cedis to spend on. What do you think the answer would be? Will be greater than or equal to, less than or equal to? Because the household has 300 cedis to spend, meaning the household shouldn't spend, like, you can't spend more than what you are having. Maybe I'll bet because you're having 100 cedis, you go to the market, like you are new at the place. So how can you spend 200 cedis whilst you're having 100 cedis? You get it? So you can't spend what you have. Good. So this is what the expression means. So this is the expression. Okay. So I think we'll end here. The next time we meet. Okay, let's try to solve this question then. Close the day. Tomorrow, God willing, when we meet, we solve for the rest. Okay. Yeah, read it for me.
An investor has 1 million Ghana cedis to invest in 3 assets. The annual market returns of the assets are 10%, 13%, and 12% respectively for asset 1, asset 2, and asset 3. To avoid market risk, the investor has been advised that amount invested in assets 2 and 3 must not exceed 650,000 Ghana cedis. How much should be invested in each asset? The investor wishes to realize a total annual income at least 6% of the total amount invested. Assume that 1 million Ghana cedis must be fully spent.
Okay, so this one, how are you going to define a decision variable? How many decision variables are we having?
It's 3.
So let X1, S2, and S3 represent what? Represent what?
The number of.
It's not always number of. Read this one. Represent. When you read the first statement, you have to get what you use.
Asset to be invested.
They are talking about money.
Assets
so amount. Their amount to be invested. So they were talking about money. So amount to be invested in what? Assets. 1, 2, and 3 respectively. Okay, so first of all, we are saying an investor has 1 million to invest in 3 assets. So what do you think the expression would be? Let's take it one by one. How do you think the expression would be? You are having 1 million to invest in 3 assets. So when you add up all the 3 assets, it shouldn't be higher than what? The 1 million.
X.
So X1 plus X2 plus X3. You're having 1 million to spend to have something to spend. So it's what? Less than or greater than 1 million. Okay. Less than or greater than what? 1 million.
Less than 1 million.
Yes. So less than or equal to 1 million. Now this is the first one. Now we've formulated the first expression. Now let's move on to the second one. The annual market returns. The annual market returns of these assets, of the assets, are 10, 13, and 12 assets, 1, 2, and 3. Now we don't know the amount to spend on what asset in asset 1, asset 2, and asset 3 to be invested. We don't know the amount. It's just S1, S2, and S3. And we are seeing the returns we are expecting if we are to what? Invest in these assets. We are getting 10% on asset 1, 13% on asset 2, 12% on asset 3. So it's going to be 10% is 0.1, right? 1.10 times X1 or 0.1 X1 plus 0.13, 13% of asset 2 plus 13%, 12, 0.12 of asset 3. Then when you read this part, the investor wishes to realize a total annual income at least 6% of the what amount invested. So how do you think? How do you think the answer will be? Which side are you going to choose? Yeah, which side are you going to use? You are seeing at least. So what do you think? Total annual income at least greater than or equal to 6%, 6% of the amount invested. So 6% is what? 0.6 of the amount invested. So the 6% of the amount invested was 1 million. So 0.6 times 1 million. 1, 2, 3. That will give us 0.01 X1 plus 0.13 X2 plus 0.12 S3 greater than or less than 6% of 1 million is 0.6 times 1 million. We're getting 600,000. And yeah, we are done with equation 2. Okay, expression number 2. Because this one is inequality, so we can't say equation. And it means when you say equation, it means it's what it is same, it is equal to something. Now let's read the third one. To avoid market risk, No investment has to deal with what? Risks. Betting stars, lottery and stars, it's all investment, but there's risk attached to it. So to avoid risk, the investor has been advised that amounts invested in asset 2 and 3 must not exceed 650,000. So what are the variables? Like what variables are they talking about? Asset 2 and 3. So what variables are they talking about? Decision variables are they talking about? What variables are they talking about? Hello. What variables? So the asset 2 and 3, meaning they are talking about X1, X2, and X3. Asset 2, and the N here means plus this and this. Meaning you are adding it. S3 must not exceed 650,000. Must not exceed. Must not exceed means less than or equal to. You can't spend more than that. So this is how your expression will be. So this program here, these are the 3 mathematical expressions we are going to get from it. All right. So any question before we close for the day? Any question? Okay. I think you understood it. So thank you for making today's class successful one. I urge you all to like, subscribe, share, and comment to our YouTube video. All right. Let's hope for more videos. Bye.